about is the greatest common factor. Okay, so the greatest common factor is the biggest number you can divide out of two factors. So just doing numbers first, if I have, let's start 15 and 25. So the greatest common factor, what's the biggest number I can divide 15 and 25 both by? 5. So a lot of these you can look at and tell. Just to break it down, the mathematical way of doing it is actually to do a factor tree and say 15 is what, 3 and 5, and 25 is 5 and 5. And then the numbers that they share are your greatest common factor. That's the mathematical way of doing it. To me, I don't even do it the mathematical way. I would do it to check yourself to make sure it's right. I know you can see this one easy, but you can just divide both of them by the number that you come up with. So 15, that'd be 3 and 5. Is there a number I can divide 3 and 5 both by? No, so my GCF is 5. Let me see if I can't get you on one here. What about 18 and 72? What's the biggest number I can divide both of them by? 9. So the first side is 9. So if you divide both of these by 9, I get 2 and 8. What can I divide 2 and 8 by something? 2. I can divide both of those by 2, and then I get 1 and 4. Can I divide 1 and 4 by something? No, I mean, besides 1, that's all. So since I divided by 2 numbers here, if you multiply these back together, that means I could have actually divided by 18. I could divide that by 18, I could divide that by 18. And that's, to me, is the easiest way to find the GCF, because y'all can think of something quick to divide it by, and then just kind of keep dividing until you work it all the way out and multiply those numbers back together. The factor way, though, the factor tree way right here, we're going to talk about. Yeah, we'll talk more about that next section, I guess. All right, so if you have numbers, if you have why cannot think of numbers 20. So here, if you have these right here, first of all, just looking at the numbers, what's my greatest common factor of the numbers, 12 and 24? I can divide both of them by 12, and just to check it, you get 1 and 2. So yes, 12 is my greatest common factor on my numbers. The way the exponents work is you take the smallest one. It's technically taking the smallest one. What happens here is I have 2 x's, and then I have 5 x's. So again, what I'm doing is I'm taking these, and then I don't have any more to take from here. So either you just take the smallest amount. So my greatest common factor is 12x squared. Again, just take the smallest exponent is the easiest way to think about that. All right, so here, what is my GCF of the numbers? Just going to be 2. What's the biggest amount of x's I can take? 5, so I can only take 5 because I couldn't take more from this one. What about y's? 1, so this is a 1 right here, so it would be 1. All right, so that's just looking at the greatest common factor of those terms. The next part is actually pulling the greatest common factor out of a polynomial. So if you have this right here, so you have 3 terms, same thing, we're just kind of looking at them individually. What is my GCF of 4, 8, and negative 10? 2, right? So I pull out a 2. How many x's can I pull out? 2 here, 3 here, and 1 here. So that means I can only pull out 1, because that one's stopping me from pulling out any more. And my y's, 3, 4, and 5. So what's the biggest amount I can pull out? 3. So now what I'm going to do is take the 2x and 3 y's from all of these. So if I take 4 divided by 2 is 2. If I take one of those x's, I have x. If I take 3 of those y's, I don't have any y's left. Here, if I do 8 divided by 2 is 4. I take away one of these x's, I have 2 x's left. Take away 3 of these y's, I have 2 y's left. 10 divided by 2 is 5. Take away one of these x's, there's none left, right? Take away 3 of these y's, I have 1 y left. So I get this right here. So you take your GCF out of each of those, and then you're taking it away from each term. You can distribute back here. You can distribute these back and end up back here at your original one to check your answer. Okay, so a lot of these are a lot easier than that problem right there. Well, some of them may be a little tougher. But the ones we're kind of going to look at are ones like this, 15x cubed. Ones like this right here. So here, what's my GCF? 5 what? 5x, because there's only one x here, so that's stopping me. So if I divide that by 5, I get 3. Take away one of those x's, I have 2 x's left. Divide that by 5, I get 5. Take away one of those x's, I have an x left. Divide that by 5, and I have 2. Take away one of those x's, and I don't have anything left. GCF isn't too much new. Y'all have seen that before? It's not too bad. Which we'll continue to do, and GCF is a very, very big part of this because it doesn't have to be exactly. All right, so one like this. Again, my numbers here are a little bit tougher. You can't think of that just right off the top of your head. So what's the number I can divide 28 and 98 both by? Just divide it by 2 to get it smaller so we can look at it. So then I'd have, what's that, 14 and 49? Well, what can I divide 14 and 49 both by? 7. Can I divide 2 and 7 by something? No. So my GCF here is 2 times 7, which is 14. Okay. So my GCF of the numbers is 14. How many A's could I take out? What? It would be 6, right? I have 6 here and 8 here, so that means I can take at least 6 from both of those. 7 and 5, so that would be 5. You just take the smaller exponent. 4 and 2. 2, you take the smaller one. So again, you don't have to think of a really big number here to divide this by. Work it out like this, and then whatever numbers you divide by, just multiply them back together, and that will give you the GCF. Do one more of these. Which one do you want to do? That one or that one? All right, so the next thing in this one is factor by group.